Geometry Students Part 2 of the Unit 3 test, Parallel and Perpendicular Lines. Let's get to it. Now I'm looking at this one, and we're going to be using the formula for slope. Slope equals y2 minus y1 over x2 minus x1. I labeled these for you and I set them up. All you have to do is finish them up. So here's Q and R, x1, y1, x2, y2. I labeled it. Here's ST, x1, y1, x2, y2. And I set them up. Here's my QR, here's my ST, here's my y2 minus my y1 and my x2 minus my x1. A minus, a negative becomes, because that was a negative over here, becomes a positive, okay? So when you look at these, you'll see minusing a negative, subtracting a negative is going to be a positive. So when you work these out, and you could simplify them and do whatever you need, if they end up being the same, that means they're parallel. If they are the opposite inverse, meaning one's positive, one's negative, one is in fraction form flipped over the other. The opposite inverse, that would be perpendicular. And then neither would be different. If they're just both different, that means at some point they're going to be intersecting, so they're not parallel. And perpendicular is intersecting, but it's intersecting at a 90-degree angle. So that's why it's going to be opposite inverse slope. Okay, I set up this one for you too, as you can see, and you can just take a look at those problems, work them out for QR and ST, and then if they're the same, perpendicular, or neither. The same, parallel. If they're opposite inverse, then they're perpendicular, or if they're different, then neither. Okay? Let me give you an example of perpendicular. So like if you had 4 and then you had negative 1 over 4. These two are opposite inverse of each other. Okay, let me give you another example of perpendicular. Let me write it over here. Say you had like negative 2/3. The opposite inverse of that is 3 over 2. Okay, it's flipped and it's opposite. It's, negative becomes positive. So there's a couple examples of perpendicular, if that helps. Okay, moving on to these. You'll see that I set this problem up also, still using that slope formula. You guys slow this down because, there's a lot to these and I'm just kind of rushing through it because my upload time takes a lot longer when these videos are longer. So x1, y1, x2, y2, x1, y1, x2, y2 for these B, C, and D, E. So parallel, whenever you see these lines, that means parallel. Just like the L's in parallel, those two lines should remind you of the two L's in parallel, so that means they're parallel. Okay, so I set up my BC and I figured out what the slope is going to be for BC. Now remember, if it's parallel, it's going to be the same slope. So I set up my CD, but there's an X value here. And as you're working it out, you'll notice that in order for it to be the same, this number down here needs to be a -6. So in other words, what number X is going to make that X plus 1 equal a -6? So then this becomes 4/3. That's going to be your answer. Okay, take a look at this one. I set this one up the same way, so you could pause it, take a look at it. We want perpendicular though. It's going to be the opposite inverse, what I was talking about. So the slope for WX is -2. So the opposite inverse is going to be a +2, but it's going to be 1 over 2. So it's going to be a half. So in order for this to become a half, a positive half, this YZ has to, this 1 minus Y has to equal a -3 in order for this to become 1/2. So what number would you put in here to make 1 minus it become -3? That's what your Y equals. For this one, which line is parallel to the line given below? I took the liberty of taking all of these and putting them in slope-intercept form. At the end, you'll see slope-intercept form. You want the same slope for parallel. You want the same slope to be negative 5 over 2. So you want the same slope. So take a look at those, and you'll see which one is going to be parallel, and put your answer in that box. Perpendicular. You're going to want to have opposite inverses, or, I didn't even write anything for this one because it's actually easier than that. If you think about it, there's going to be a couple of these there's going to be one that's no slope and one that's undefined. That means that they're going to be, one's completely vertical, one's completely horizontal. That means they're going to meet perpendicularly. So that's why I didn't write anything, because there really isn't anything to write with this one. Figure out which one's undefined and no slope, and then that's going to be your answer, A, B, C, or D. Okay, for the last page, we are going to use the point slope form, which is y minus y1 equals m times the quantity of x minus x1. And take a look at it. What I do here is in order to get that y by itself, you have to add a y1 to both sides anyways. So that's why my formula looks like this. I have added the y1. I went ahead and did that to make life a little bit easier. Okay, make it quicker. Parallel, we want the same slope. So I figured out for this equation, 3x minus 2y equals 14. I figured out the slope. I put it in slope-intercept form, get y by itself on one side. So the slope has to be 3 over 2. So, and here's the point, negative 6, negative 11. So I plug in my slope, 3 over 2, and I put in the points. My subtract x1, so that's adding 6. Subtract 11, work this out, and this will give you the equation. So work this out, use the distributive property, combine your like terms, and then that's going to be y equals whatever you get. I took you very far on that one. This one too is the same thing, but now you're going to get the opposite inverse because it's perpendicular to this line. I went ahead and I solved to figure out what the slope is for this equation, and the slope is 1/3. So the opposite inverse of 1/3 is a negative 3. So the slope's got to be negative 3. I plugged in my x1. I plugged in my y1. Solve this, and you'll get y equals something x plus or minus something, and then that will be your answer for that one. Okay? Hopefully this all helps for unit test 3. If not, that's about as far as I can guide you, but if you have any questions, please make sure you're Zooming me during class time, study hall time. I sit here with my Zoom in front of me at all times, and you could ask questions then. So good luck.